Hey Evergreens, I have a math problem and I need your help. Here's my dog Dunk again. Dunk loves to play fetch. You ready, boy? Go get it. Good boy. In this problem, we are going to write, graph, and solve a system of inequalities to help me figure out the different possibilities for the amount of time it takes Dunk to bring the ball back and how far I throw the ball when we're playing fetch. I know that the amount of time in seconds, S, that it takes Dunk to bring back the ball is always at least 10 more than the number of feet that I've thrown the ball. I also know that Dunk always brings the ball back in less than 1 minute. When I say go, take 30 seconds silently and independently to write a system of inequalities that represents this scenario. Go. And come back together in 3, 2, 1, time. When writing my system of inequalities, this is what I came up with. Now, it doesn't seem quite right to me. When I say go, turn and talk with your partner, what misconception did I have when I wrote this system of inequalities? Go. And come back together in 3, 2, 1, time. The misconception I had is that I used two different units here. The 1 is the time in minutes, while S is the time in seconds. So I should have written this as S is less than 60 and S is greater than or equal to F plus 10. The next thing we need to be able to do is to graph this system of inequalities. When I say go, take 30 seconds to identify which graph accurately shows this system of inequalities and be sure to justify why your answer choice is correct. Go. And come back together in 3, 2, 1, time. When selecting our graph, we should choose option 4. This is the only graph that has the correct boundary lines and the shading in the correct direction. Since S is less than 60, I should have a dashed boundary line with the shading below the actual line. Since we have S is greater than or equal to 10 plus F, I should have a solid line with the shading above. Now that we have our graph, we need to be able to identify what points are solutions. You have 4 different labeled points on your graph, points A, B, C, and D. When I say go, silently and independently determine which point is a solution. Go. And come back together in 3, 2, 1, time. In this case, only point C represents a solution. Point A, where the 2 boundary lines intersect, would be a solution if we were looking at a system of equations. However, this point will make only 1 out of our 2 inequalities true. Thanks, Evergreens. I knew we could count on you.